Hi everyone. In today's challenge, we are going to solve this problem. The problem name is fair distribution of cookies, and the problem number is 2305. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, Python, and JavaScript programming language. Fine, guys. Now let's see what this problem says. Right. So problem says you're given an integer array cookies where cookies of I denotes the number of cookies in the ith bag. So we are given first of all an integer array. The array name is going to be cookies. So let's insert some integer values 2, 4, 5 and 6, right? Now on each index, let's say this is 0 index, this is first, this is second, this is third, right? So on each index, so in 0 index, that means on 0th bag we have nothing but 2 cookies, right? You can see if the value is 2. On first index, that means on first bag we have 4 cookies. On second bag we have 5 cookies. Similarly, guys, right? So this is nothing but we have one cookies array. Now you are also given an integer k that denotes the number of children to distribute all the bags of cookies to. So simple thing, guys. One more thing we are given, that is nothing but k, which is going to be an integer, right? So it's going to be have an integer value. Let's say it is a 2, right? So that means we have a 2 children. We have to distribute all these cookies to these 2 children, right? I hope it makes sense. So k represents the number of children, total number of children. Cookies represent the total number of cookies we have in the bag, right? Bag is nothing but the length of an array, right? So total bag is going to be total the length of cookies array. So we have to distribute all these cookies to these k children. That means to these 2 children, right? I hope it makes sense. So now this is all the cookies in the same bag must go to the same child and cannot be split up. So let's take any cookies. So let's say I'm taking a cookies from first bag, right? So this is nothing but 4. So we have 4 cookies in first bag, right? Now, guys, we can distribute all the cookies to only one. We can say exactly one children, right? These 4 cookies either go to first children or go to second children. But we cannot split up into 2 part or 3 part like 2 and 2. Let's distribute 2 cookies into first children and 2 cookies to second children. No, we have to distribute all the cookies to exactly one children. So that means the cookies which is present in a bag, that must be go to exactly one children, right? So 4 should go to exactly one children, 5 should go to exactly one children, 6 should go to exactly one children, and 2 also should go to exactly one children only, right? The children can change, like they can go to first children, second children, or any children, right? But they all should go to exactly one children only, right? Now the next line, unfairness of distribution is defined as the maximum total cookies obtained by a single child in the distribution. So now, guys, what is unfairness here? Unfairness means the maximum cookies a children are able to get in this particular distribution, right? So we have to say unfairness is nothing but the maximum cookies are get by the children, right? Maximum cookies get by the children, right? That will be called as the unfairness, right? So now what we have to do, we have to return the maximum, not maximum, we have to return the minimum unfairness of all the distribution. So which means, guys, we have to return the minimum unfairness. That means we have to make a such distribution such that all the children should get at least equal, or we can say the less difference, right? So if you are not getting this part, let me tell you, we have to distribute all these cookies to these 2 children such that the unfairness should get minimum, right? Unfairness should get a minimum. So let's take in this example only. We have 2, 4, 5 and 6 cookies, right? So let's say I distributed, this is the array. The first children got 0 right now, second children also have 0 cookies, right? So let's say I am inserting, or I'm giving these 2 cookies to the first children. So first children will have now 2, and the second children will gonna have 0 only, right? The next cookies, this is 4, I'm giving to the second children, right? So second children will have 4 cookies now, right? So here the maximum, we can say the minimum unfairness is 4 only, right? Now we have to do like 5. We have to distribute these 5 cookies to, let's say I'm distributing this to the first children, or let's say I'm distributing this to the second children only, right? So this is going to be nothing but 5 plus 4 is nothing but 9 only, right? And this 6 I'm distributing to the second children, first children. So this is going to be nothing but 8 only, right? So now, guys, here you can see we have make this one possible distribution. We have distributed 2 and 6 to the first children and child, and 4 and 5 to the second child, right? Now once this is done, we are going to find the maximum, the who got a maximum cookies. So second children got maximum cookies, and that maximum cookies is nothing but 9. So this is nothing but our unfairness, and we have to minimize this particular unfairness, right? So we have to do distribute such that we should get a minimum, right? So here we get a 9 max unfairness, which is the minimum possible distribution. If we distribute in any other way, let's say I distributed 2 and let's say I distribute 2 and 5 in one place, and 6 and 4 in one children, right? So 7 goes to the 0 child, and 10 cookies goes to the first child, And now you can see the maximum here unfairness is nothing but 10 only. So which is the maximum, 10 or 9? So 9 is the minimum, right? Which is the minimum, 10 or 9? So 9 is the minimum unfairness. So we have to make a possible distribution such that we can get a minimum unfairness. So here our best distribution is nothing but this one, 8 and 9, and we have to return 9 only, right, in the output. I hope it makes sense. So this was the basically problem understanding part. What we have to do, we have to basically distribute our cookies to all the key children such that we should get a we should minimize the unfairness, right? And unfairness is nothing but the maximum cookies get by any children. So all right. So now let's move to the example and let's try to understand from the example how we are getting the answer, right? So here in example one we have these cookies and case two, right? So now what we have to do, we have to distribute all these cookies to the exactly two children, right? And such that we can get a minimum unfairness, right? So here they have distributed 8, 15 and 10, 8, 15 and 8 to the one cookies. So they are gonna get total 16 and 15, nothing but 20, no 31, and 10 and 20 to the one children, that is nothing but 30, right? So 0 child have 131 cookies and first child has 30 cookies, right? So the max here unfairness is nothing but 31, and this is only the minimum unfairness from the all possible distribution. If you try to distribute in other way, let's say you are giving 8, 10 and 20 to the one child, this is on 38 and second is going to 23. So here unfairness is 38, which is not a minimum one, right? So this is 31 is the only minimum unfairness we can get by distributing all these cookies to these two exactly children. So output as well 31, right? Now let's move to the second example. Here you can see we have to distribute all these cookies to the exactly three children. So how they have distributed? They have distributed 6 and 1 to the one child, 3 to the second child, and 4 1 to the second child, right? So they are getting a maximum minimum unfairness in nothing but 7 only, right? So you can try this by writing on the copies, or like you can try this by manually. You will find that this is the only best possible distribution you can get to get a minimum unfairness, right? So that's what the basically problem understanding part. I hope you understood the problem in the statement and the example as well. If you have any kind of doubt in this, then you can write in the comment section. I'm always there to help you. But this part should be clear to you, right? So then only we can move to the next part, that is nothing but logic part. So let's move to the logic part, right? So what we are going to do, we are going to remove this all. So here, let me write a logic. Fine. So what we are going to do, guys, here we are going to find we have to do such that the people, or we can say the children, should have nothing but we can say minimum cookies at the maximum level, right? Minimum cookies at the maximum level. We have to just minimize that part, right? So if I just make this array 8, 15, 10, 20, and 8. So what is our goal? We have a two child here, right? K is equal to 2, that means there are going to be two children, right? So we can make an array of the two children. Let's say this is an array. So here we can say initially both have 0 cookies, right? So now what is our main goal? Main goal is nothing but we have to minimize the maximum level, right? We should not keep putting all the cookies to the one child. This will going to increase our maximum level, right? So we have to minimize that maximum level, nothing else, right? So how we can do this? So for the simple logic, guys, we have all these cookies. We have to do the recursion part. We have to give all the possibilities, right? So what I mean by all the possibilities, nothing but we have this array, right? So initially we can say just give this eight cookies to the first child. So this first child will going to have 8 cookies now. The second child will have 0 cookies. Otherwise, give this 8 cookies to the second child. So first child will going to have 0 cookies, 8 cookies. The first zero child means the zero child will going to have 0 cookies, and the first child will going to have 8 cookies, right? So now guys, this is the we can say the two possibilities for only one cookies, right? So here you will see the unfairness is nothing but 8 only, right? So we have to take the minimum on this level, which is nothing but 8 only. So we have only one cookie is 8. So one unfairness, or we can say result, is going to be nothing but always 8, right? So now let's move to the next cookies, that is 15 now. So what we are going to do, we are going to say fine. So in on this, either you can give this 15 cookies to the first child. This is nothing but 8. So 8 plus 15 is nothing but 23. So first child will have 23 and second child will have 0 only, right? Or what you can do, you can say give this 15 cookies to the second child. So 8 and 15, right? Same thing you have to do, give to the other first child. So 15 comma 8, give to the second child 0 comma 23, right? So here on this level, if we have two cookies 8 and 15, so our unfairness is going to be nothing but minimum of all these unfairness, right? So here in this unfairness is 23, in this 15, this 15, this is 23. So minimum is nothing but 23 only, right? So we are going to say nothing but 23. So no, minimum is nothing but 15 only, right? So 23 is the maximum one. So here 23, here 15, here 15, here 23. So we are going to return nothing but 15 only, right? So in this level, if we have only two cookies, but we have more cookies, so let's do for 10 as well. So we are going to say give either 10 to this first children, so 33 comma 0, or either give 10 to the second children, 23 comma 0. For this as well, we have to do give either to the first children or give either to the second children. Here also here also. So this, but after this, in this level we are also going to cover this, we can say second third cookies as well, 10. Then we have to do for 20 as well, right? For these we have to do 20, and for again we have to do 8, and then we are going to say this this level we are going to find the minimum all these possibilities, right? We are going to find the minimum unfairness from all these possibilities, and we are going to return that particular part that will always going to be 31 only, right? I hope it makes sense. So that's how we are going to solve this problem. This is nothing but a simple recursion, nothing else. We are using a simple recursion, nothing else, guys. I hope it makes sense, right? So we can do this particular part in our code, and we can implement easily our this particular logic, right? So let's move to the implementation part, and let's implement this logic. So what we are going to do, we are going to first of all with the Python programming language. So what we are going to say, we are going to say, let's define first of all check it if k is equal to length of cookies, means if total number of children is equal to the total number of cookies. So let's split all each back to the each children, right? So we can simply say if k is equal to length of cookies, so return maximum of cookies, right? But if it is not the case, so what we are going to do, we are going to say, okay, just first of all make an array for each children. And so I'm going to say distribution is going to be nothing but 0 into, here I'm going to multiply by k. That means I have distributed 0 cookies right now for each children, right? Once I have done this distribution, I'm going to say result also going to be nothing but equal to 0. Fine. Result is nothing but is going to tell us that how many minimum unfairness we have right now, right? Fine. And here we are going to define one more function, solve, which is going to be nothing but our recursion function. Here we are going to say index. If index is equal to length of cookies, that means we reach to the last level. We reach to the last level, that means we have to find the minimum one. So we can say result is going to be nothing but minimum. So you have to take minimum from result, or this is not going to be 0 initially, it's going to be nothing but, we can say float infinity, right? Because initially we are taking a maximum, right? So now we are going to take minimum from result and the minimum of distribution, right? Distribution. So let's define this function over here, control X and control Y here, right? And here we are going to say non-local result and non-local distribution, right? Now once we have taken this thing, we are going to take a minimum from result and maximum from distribution. And why I'm doing this, I hope you are getting this particular maximum distribution is nothing to tell us the unfairness, right? Unfairness on this particular level. If I go to this particular code, this is nothing but, we can say, if we take a maximum of these two, right? So this is nothing but to give us some unfairness. Now we have to take this unfairness minimum one. Here you can say maximum of this is 23, right? Here maximum of this nothing but we can say 23. Here maximum of this nothing but we can say 50, and here nothing but 15. Here nothing but 23. We are taking a maximum from each array and we are minimize it, right? So same thing we are doing. We are taking a maximum from each array and we are minimize it from result, right? Once this is done, we are gonna return, right? And here, if it is not equal to the length, we are not at the last level, so we are gonna say fine. First of all, check if our result is smaller than or equal to the maximum of distribution. So you have to directly return as well, right? Let's say we are exploring this particular part now, right? And we have already got minimum and this part having a maximum, right? So let's say I'm saying just saying that I have got a minimum value, right? So let's say I've got a minimum value in this level. Let me change the color. Till this level I have got a minimum one, right? And I'm traversing on this level now, right? So I found that here we have an array 30 to 35, right? So here you can see maximum is nothing but we can say 35, right? Always it's going to be more than or less equal to this, right? In the next level. So we don't want to explore there as well. We'll say move to the next part, right? Simple thing, guys. So if maximum distribution is greater than our result, so we're going to say return. We don't want to explore this particular level. All right, now we are going to say for we can say I in range of k for each student or student not children, distribution of I is going to be equal to plus equal to cookies of idx, right? First time you that means you are distributing these cookies to this children, right? Now you are calling this function for index plus 1. But also you are we can say distribution of I minus equal to cookies, which means for the next cookies I'm assuming that we haven't given these cookies to these children, right? So we are just subtracting this by cookies same, we can say same cookies, so that for the next iteration our we can say distribution of array should not get affected, right? So next iteration we are going to give the same cookies to the another children. For next iteration we are going to give same cookies to the another children, right? So this is nothing but we are distributing these cookies to all the children, right? Once after that we are going to say return, and here we don't need to return anything, just by default we're going to return a null. So fine, after that what we are going to do, we are going to call this function for 0 and we are going to say return our result. So let's see whether it's working fine or not. I hope it should work, right? So we have done almost all things, but the only thing which we have done wrong is nothing but here we are having a spelling mistake, right? So fine. So we don't want to see any more error. Code should get a pass, right? You can see, guys, it's successfully good pass. So let's try to submit this code as well. And by this, we are going to submit with a Python programming language. It is a simple question, right? We have to just calculate all the possibilities, right? So you can see, guys, it's successfully got submitted. Now let's move to the next programming language quickly with that in H1 C++. Here, first of all, now I'm going to increase my speed. Here we are going to say, first of all, check if k is equal to length, not length. We can say cookies dot size, or we can say length as well. Of size is equal to, if it is equal to k, then we are going to say return nothing but you have to return maximum, right? So max of cookies, not max element, right? Max element cookies dot begin, let me begin, and cookies dot end, right? So we are going to do this thing, and here we have to use gin, and here, guys, we have to use star object or asterisk, right? Once this is done, we are going to say fine. If it is not equal to the case, that means if it is not equal to the k cookie size, then what we are going to do, we are going to define first of all a vector of integer size, and the name we are going to give nothing but let's give distribution only here as well, distribution. The size is going to be k, and by default value is going to be 0. After that, we are going to define one more variable that will nothing but result, right? It is going to be nothing but equal to 0, not 0. It should be maximum value, right? Int max. Fine. Once this is also done, we can define this first value to the top, right? So that we can use in our function without passing in the argument, right? Fine. Now we are going to call one function. That function name is going to be nothing but solve only. We are going to call it 0 index. We are going to pass cookies. We are going to pass k. We are going to pass, let's say, nothing but what we can pass as, we can pass our distribution, right? Distribution, right? Fine. We are going to after that return our result. Let's define this function as well. So we are going to say void solve, and here in this function we are going to say fine. First of all, you are going to have index. Then you're going to have this two thing vector of ints cookies, this whole things. So let me define these two things as well. Fine. And here after that you're going to have distribution, right? Vector of int, you can say fine, and here distribution, right? Fine. Once this is done, you are going to say here if our index is equal to the cookies dot size. So what you are going to say, you're going to say nothing but return, not return. You have to first of all find a minimum. Result is equal to maximum, we can say, let's calculate the above only, right? So we are going to say here into maximum number from our distribution array is nothing but you can say star max element is of distribution dot begin distribution dot end, right? After this, we are going to say result should be minimum of result comma maximum. And here, if this is not the case, if this is the case, so we are going to return it. But if it is not the case, so we are going to say fine, come out this, check if your result is already less than or equal to this maximum. So you're going to directly return this, right? If it is also not the case, now you're going to distribute each this cookies to each children, right? One by one for get all the possibilities, right? So for int I is equal to 0, I less than k, I plus plus. Here you're going to say I'm going to distribute. So distribution of this I plus equal to cookies, right? That means I have distributed this to I, right? Fine. And after that, we're going to say call this function solve index plus 1, cookie is going to remain same, and k remains same, distribution also. We have to like this, right? Fine. After that, we're going to say, okay, now once we have called this function for this, we can say children. Now you have to reduce this cookies by 1, and after that, you have to call for next iteration, right? So that's all. Now let's run this code and see whether it's working fine or no. So let's see, right? Here I have put a capital letter R, so I know this is gonna give an error. So what's happening here? Fine, right? Okay, now it should write. So let's see. I have again used a main. I don't know what's happening. All right. So let's see. So now fine, it's giving an error here. Cookies dot end and cookies dot begin. And what we are doing, we are using a comma, right? Fine, we can say it's comma. It's cool. So it's saying that expression after on cookies or dot end. Alright, so we are saying return max element. Fine, we don't need to use like this. Right, so what we are doing actually here, result unused if cookies dot begin, this cookies dot begin, this cookies dot end, and we're returning a maximum of this, right? Fine, so that's cool. Okay, we are using an int variable, right? I don't know why we are using if we have to use I don't know why we are doing this much mistake. Fine. Now you can see, guys. I hope both the test case pass, but no, they fail. The reason is nothing but we are choosing a minimum result and a maximum, right? Max element from all this distribution of n, distribution of cookies. Fine. And we are taking int max. We are taking always minimum. That's cool. It should be output 31, right? So we have to take a max element from distributions. All right. So we are passing a distribution dot begin distribution dot end, which is going to calculate the maximum from this. We can say distribution vector. After that, we are gonna check if size is same, then we are gonna return minimum. If result is less than or equal to maximum, so directly return. If it is not the case, so move to all the children, and this distribution of plus equal to k, and distribution I is that as well. Right, fine. Let's see here as well. We are getting output 6, but it should be 7, right? So okay, so we are getting a result. We are passing 0, we are passing k, we are passing distribution, right? Fine. Everything is looking fine here, guys. In max also it's fine. So what we can do here, we can say index plus 1 comma cookies comma k comma distribution. It's fine, right? We're passing with this value, well we can passing this that as well. Okay, if index is size, then we can return a minimum, and we can do like that, right? Fine. It's also the cool way. So what we can do, we can try passing result area as well here, result, and here let's say result is nothing but int max, right? And we can also pass here result int result, and here we can also pass our result, right? And here we can comment this line. Now let's run this code and see whether we are getting a right output or not. But we should get right. Earlier code also was fine. So here the same thing, right? That means that does not get affected. Cookies we are okay, guys. So we got an issue. We have to nothing but we have to just write here index, right? Finally we got an issue. Let's try to run this code now. It will definitely get submitted. Sorry for this time, guys. I know time is very important. So let's try to submit this code, right? So we can see. So it will get submitted. Fine. You can see, guys, we successfully submitted with C++ as well. Now let's move to the Java. And here in Java, what we are going to do, we are going to first of all say int result. So let's give a result here, int result, which is nothing but integer dot max value. Fine. And here we're going to define a public so void sol, definite sol. And here we're going to take first of all index, then we're going to take int cookies, then we're going to take k, then we're going to take distribution, and here we're going to say first of all fine. In distribution we are going to check if our this index is equal to the cookies length, then we are going to find if it is equal to the case, then we are going to say your result should be minimum math dot minimum, and here you're going to pass a result and your maximum number from your this distribution array. That can be called easily by, let me go here, then we can say int maximum is nothing but gonna be your array store string, and here you can pass your distribution, and you can pass a max, and here you can pass to get as int, right? After that, once this is done, we are going to check if result is already less than or equal to our maximum. That means we don't need to pass this level, right? We can simply say return. But if it is not the case, so we are going to move to all the children's int I is equal to j, let me write j I less than k I less than plus plus, right? Here that means we are moving to all the children, and we are going to pass these cookies to all the children, right? One by one. So we are going to say distribution of I plus equal to cookies dot index, right? And here we are going to say distribution node, we're going to call this function index plus 1, and here we're going to say cookies going to remain same, k remains same, distribution remains same, right? After that we're going to decrement this distribution of I, distribution of I of minus 1 minus equal to, and here we're going to say cookies of idx, right? After this we are going to return, right? So we don't need to write return here because this is void. So we can simply say here if our cookies dot length, if our cookies dot length is equal to k, which means nothing but we have exactly k children with exactly we can say bag, right? So number of bag is equal to number of children. So what we can say simply return this, we can say arrays dot stream, we can pass here cookies dot get, we can say maximum, and dot get as int, right? Get as int. I hope it makes sense. Now once this is done, we are going to say if it is not the case. So first of all, create an array. Here you can say distribution array, and then new int of size k, and by default you have to fill the value 0, right? By default it takes 0 only, right? So you can say now your result variable already defined there. So let's call this function so 0 cookies k distribution, and you can simply return here result, right? So let's see whether we are getting any error or not in Java. I don't think we should get, right? We already faced so many errors, but again we got that is solved. Again a spelling mistake. Now let's run this code. So let's see. One more error, that is nothing solved 0 keys case. Now what's error? Cannot find a simple solve. Alright, so I have been on the wrong side. So this should be nothing but solve, right? Fine. Hopefully it should pass. You can see guys, both the test case pass. Let us submit this code, right? Finally it will also get submitted. Definitely it will gonna submit. So you can see guys, it definitely got submitted. Now let's move to the last programming language, which is nothing but JavaScript. Finally we come to the last programming language here. So we are going to say nothing but first of all find a length, or we can say if k is equal to keys dot length. So we are going to say nothing but return. What you have to return? You have to return maximum value, right? So how you can get a maximum value? You can say math dot max spread operator, and here you can pass nothing but your cookies. Simple thing, right? But if it is not the case, then what you are going to do? You are going to create an array first of all. So you can say const. The array name you can say distribution, and here you can pass nothing but array or new array of 5, right? Not 5, here I'm just 5 k, right? And here I'm going to say for let I is equal to 0, I less than k, I plus plus, I'm going to say nothing but distribution of I is going to have nothing but equal to 0. By default they're going to have 0 keys, right? After that we're going to say call one function, right? So I'm going to say const sol, the function name we are having a sol, this is going to be take first value, that is index, and that is also going to be like this, right? And here we have to define our result variable as well, which in nothing but initially going to be infinity, right? All right, so here we are going to say if our index is equal to cookies dot length, so we can say simply return, not return, you have to calculate the spread operator, that maximum value, right? So you have to calculate the maximum. So we can say let maximum is nothing but equal to math dot max 3 dot, and here you can pass your distribution, so distribution, right? After that what you're going to do, you're going to say max, here your result should going to be equal to minimum, and you can say like math dot minimum and result comma this maximum. Fine, and here you have to return it, right? If this is the case, so you can directly return. But if it is not the case, you have to check if result is already less than equal to maximum, so you can directly there as well return. But if it is also not the case, so you can say for let I is equal to 0, I less than k, I plus plus, here you're going to say if our, not if, you're going to say distribution of I is plus equal to cookies of, you can say index, right? And here you have to call this function now for this children, so right, and here you can pass index plus 1, nothing else, right? After that you can say remove this cookies from this children, distribution of I minus equal to cookies of IDX. Once this is done, you are gonna return it, and this is as not gonna return something else, this is void, so we are gonna call directly this function with 0, and we can simply say return our result. So let's see whether it's working fine or not. So you can see both the test case passed finally with the JavaScript programming language, right? So let's submit this code. So by this we are going to submit our logic in 3 or 4 programming language: Python, C++, Java, and JavaScript, right? So you can see guys, it successfully got submitted. So we have successfully implemented in Python, C++, Java, and JavaScript. We have also seen the logic part. We have also seen the problem understanding part. So hopefully we have seen everything right in this problem. So if you have any kind of doubt, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video, right?